One. I know in class I told you you didn't have to check, only because I want you to more practice on solving the equation, right? So let's keep that, and then we'll do solve and check on the one that is due on next week for you guys on the day of the test. So here, distributed property, no. Combined like terms, no. Variable sides, yes. So let me get rid of the smaller coefficient by doing minus 8d, minus 8d. That goes away. 9 minus 8 is just d. Minus 3 equals 12. We do plus 3. Plus 3. Cross that out. D equals 15. You're more than welcome to do a check. Okay. We should. We should. Okay. I guess I'm just being lazy, but 15 is the answer. Hopefully. Second one, take the calculator, do the distributive property here. Half times 4 is 2x. Half times 6 was 0.5 times 6 is just 3. Equals 11x plus 15. Combine like terms? No. Variables on both sides? Yes. Let's get rid of the 2x by doing minus 2x. Minus 2x. That goes away. Negative 3 comes down. 11 minus 2 is 9x plus 15. Remember, our objective is to have x all by itself isolated. So I need to get rid of the 9, the coefficient 9, and the constant. So we get rid of the constant first. So let's do minus 15, minus 15. That goes away. 9x comes down because it's the only thing left over. This becomes negative 18. Divide by 9, divide by 9. 9 divided by 9 is just x, and negative 18 divided by 9 is negative 2. Next one over here. 3n minus 5 equals distributive property 6n plus 6 times 2 is 12. Again, distributive property we just did. Can I combine these two? I can't. Can I combine these two? I can't. Variable on both sides. Let's get rid of the 3n. Minus 3n. Minus 3n. This goes away. Negative 5 comes down. 6n minus 3n is 3n plus 12. We're going to do minus 12, minus 12. We're going to get negative 17 equals 3n. This is going to go away, right? Well, now we divide both sides by 3, and our final answer is n equals negative 17 over 3. So this one I will actually check. Well, I check because it's a fraction, and we're always afraid that, hey, it's a fraction, I don't know if my answer is correct. So it's 3 times negative 17 over 3, right? I'm replacing the n with that. Minus 5 equals 6 times negative 17 over 3 plus 2. Let me highlight what I replaced. This is where I replaced, and this is where I replaced. All right, so if you had your calculator, you would just put that in and see if it works. I will manually do this. 3 times negative 17 over 3 is just negative 17 minus 5. Combine those two, I get negative 22. So on the left side is negative 22. On the right side, well, negative 17 plus 3, I'm going to change that to a what do you call mixed number. It's actually the same thing as 3 goes into 17 5 times. I'm left with 2/3. So inside the parentheses, negative 17 over 3 is the same thing as negative 5 and 2/3 plus 2. Now if we combine negative 5 and 2/3 plus 2, we actually left with negative 3 and 2/3. So I'm going to write 6 times negative 3 and 2/3, which you get to multiply times 6, and you'll find out that it does equal to negative 22. All right, so this answer works. So far, all the 3 equations we just did had one solution. Okay, careful with the next one. I know we did this in class, but I'm going to do it again. 12x, distributive property, minus 24 equals 12x, distributive property again, minus 24. Notice that the expression on the left is exactly the same as the expression on the right. What conclusion can we make here? The conclusion we can come up with is that no matter what the value of x is, the value of the expression on the left and the value of the expression on the right will come out to be the same because you're doing exactly the same thing to x on both sides. But to continue this, I mean, our next step would be to get rid of one of the variables. So let's do minus 12x, which actually ends up being the same on the other side. 12x and 12x minus 12x goes away. I'm left with negative 24. On the right side, 12x minus 12x goes away, and I'm left with negative 24. So no, notice that when you come to a situation like this, where the left side equals the right side, this is one that says there's infinite number of solutions. Right? All real numbers, or if you want the right solution, is all real numbers, because it doesn't matter what value of x we use, it's always going to be correct. 5. 8 times x is 8x. 8 times 2 is 16 positive. Careful here, it's a negative times a positive, so we get negative 9x. Negative 3 times 4 is negative 12, equals negative 1. Combine like terms, yeah, combine this guy with this guy. Be careful here, because it's negative 1x. And I'm going to actually write the 1 because that's going to help us out. 16 minus 12 is 4, positive, equals negative 1. So, how do I make that look like this, right? I want to make this equation look like x equals something. So, minus 4 first. Let's get rid of the constant. Minus 4 on both sides. The 4 goes away. This becomes negative 5. And what I bring down is negative 1x, which doesn't look like this yet. How do I make negative 1x become x? Well, we divide by negative 1 and divide the other side by negative 1. Negative divided by negative is a positive, and that's how I'm left with x. And on the right side, negative 5 divided by negative 1 is 5. And that's the solution. So this one has one solution. Okay? 6. Yikes, quite a lot. All right, 6. And again, negative, again, you're going to have a calculator, so 0.2514 is 3.5x minus a quarter of 6. 0.25 times 6 equals 1.25. And I'm going to change 7 over 2. 7 over 2 is 7 divided by 2. So imagine $7 and divide that by 2. You actually get 3x. 3.5x. Okay, so just write it a little neater. 3.5x minus 15. Okay, so now notice that the expression on the left and the expression on the right look very, very similar, but they're not the same. So definitely not infinite solutions, because if it was to be, they have to be exactly the same expression. Let's continue. There are variables on both sides. Let's get rid of one of them. It doesn't matter which one, because they're both the same. But you end up doing minus 3.5x on both sides. Minus. That goes away. You're left with 1.25. On the right side, that goes away, and you bring down negative 15. So it's 1.25 equals negative 15. It is not. So that means when you get to something like that, an equation where you have a value not equaling the value on the right, then this is an equation that has no solution. 10b, oops, no, let's do distributive property. Plus 2 minus 5b equals 2, and then distributive property here, we get negative 5b. Negative 5 times 8 is negative 4. Be careful with your signs, please. Combine like terms. 10b and minus 5b on the left side equals 5b. Don't forget the plus 2. On the right side, 2 and negative 4 can be combined, and we get negative 38 minus 5b. Distributive property, check. Combine like terms, check. Is there a variable both sides? Let's take care of that. One that has a coefficient of 5, the other one has a coefficient of negative 5, so let's get rid of the negative 5 because it's smaller. So plus 5b, plus 5b. And the reason we do that is because we don't want to deal with negative, so that's why we take care of the variable with a smaller coefficient. This goes away. Negative 38 comes down. 5b plus 5b is 10b plus 2. Again, how do we make that look like this? Well, I have to get rid of the coefficient of 10 and then get rid of the constant. Who do we get rid of first? The constant. So we did minus 2, that goes away, we're left with 10b equals negative 40. We divide both sides by 10, b equals negative 4. Okay. All right, 8. Again, decimals, 0.3x. 0.3 times negative 6. First of all, it's negative, and then we get negative 1.8 equals 0.2x plus 0.5x plus 7 minus 4. All right, let's combine some like terms. These two I can't combine, so they stay as they are. This side I can combine these two. Gives me 0.7x. And then 7 minus 4 is just positive 3. Now, notice that we have decimals, and we spent a day on clearing decimals, so let's do that. Number of decimals, the number, the coefficient, or the constant that has the greatest number of decimals is 0.3 or 0.7. It has one decimal place, yeah? You have one decimal place. What do you multiply? We multiply by 10. Remember that, right? So we're going to multiply everybody times 10, times 10, times 10, times 10. 10 times 0.3 is 3x. 10 times 1.8 is 18. 10 times 0.7 is 7x. And then 10 times 3 is just 30. No more decimals. Now we have variables on both sides. Let's get rid of the smaller one. So it's 3x. So we're going to do minus 3x here and minus 3x here. That goes away. Negative 18 comes down. This becomes 4x plus 30. Now we get rid of the constant. We'll do minus 30 on this side and minus 30 on this side. That goes away. And I'm going to write it over here. So we get 4x on one side and negative 48 on the other one. We divide by 4 now. Divide by 4. 4 divided by 4 is 1 or 1x. And negative 48 divided by 4 is negative 12. And that's my answer. So this equation has one solution. Okay. We have distributive properties. So let's take care of that. 7 minus 6.3x equals 2.5x. Distributive property happens here and here. We get minus 6x plus 15. Are you okay? All right. So can we combine like terms? We can. Okay. So I'm going to combine this guy with this guy. So that's going to give me negative 15.5x plus 7. On this side, I'm going to combine these two guys, and I'm going to get negative 3.5x plus 15. You want to get rid of the decimal? You can. If you just want to continue as it is, you can as well. So this one, I'm going to get rid of the decimal. The number with the greatest number of decimal places is just one decimal place, so there's one decimal place. And then I'm going to multiply everybody by 10. Okay, so times 10, times 10, times 10, times 10. Please use your calculator. This is going to become 155x plus 70 equals negative 35x plus 150. You didn't have to get rid of the, clear the decimals. You didn't have to. You could have just continued without doing it, but I cleared because we actually did that exercise. So get rid of one of the variables, right? There's variable on both sides. Let's get rid of the 155 because that's smaller. So plus 155x plus 155x. That goes away. 7 comes down. This is going to be 120x plus 150. We're going to subtract 50 here. We're going to subtract 50 from this side. Oh, that's 150 by the way. Sorry, let me take this back. Yeah, mistake. So that's 150. So I'm sorry, minus 150 on this side, minus 150 on this side. That goes away. Negative 150 minus 70 is negative 80 equals 120x. You divide both sides by negative 120. Right, so that goes away. We're left with x, and let's simplify that. Don't leave it as, well, first of all, negative and then negatives are positives. Don't leave it as 80 over 120. You can simplify this. Well, we can take the zeros out, and we can find a number. 4 goes into 8, and 4 goes into 12. 4 goes into 8 2 times, and 4 goes to 12 3 times. So final answer, x equals 2/3. And again, you would, on the test, come over and check, right? You're not going to leave your answer without checking. That was the front page. Now we have something else, the back, right? I think it looks like this one. Yes. Right, okay. Yeah, okay. All right. Robert bought 3 baseball caps. So how much were the baseball caps? So if I wanted to find, let me write here. Bought 3 baseball caps. What else did he write? Plus 1 jersey. And then it cost 90 bucks. Okay. So do we know the price of the jersey? Yes, we do. The price of the jersey is 24. So I can replace jersey with 24. Do I know the price of caps? Well, if I wanted to find how much we spent on caps, I would do 3 times, right, about 3 caps times whatever the value is. But I don't know the value, so I call it x. And that's what I'm going to write over here. That's the equation for your word problem. Minus 24, minus 24. That goes away. 10 minus 4 is 6. 8 minus 2 is 6. So 3x equals 66. Divide by 3. Divide by 3. X equals 22. So each baseball cap was 22 bucks. Right, it's pretty easy, right? So again, let me see. Michelle bought a box of cereal. The box of cereal has 20 ounces of cereal. So imagine a box of cereal. Right? It's full of Cheerios. And she eats 2 ounces of cereal every day. So that's going to decrease as the day goes. And then let's say this is Monday. Let's say this is October 1st. In how many days will her box of cereal look like this? When there is only a little bit of cereal, right? Obviously, it's gone down. So, when will it equal to 12? That's what the question says. You know, this is like that candle problem you did the other day. Your box of cereal starts with 20, and every day you're going to take a little bit off. So, how much? 2 per day. That's our equation. 20 minus whatever you lose per day is going to go minus 2 ounces per day is going to be 12. So in how many days will you reach 12? Well, let's do minus 20. Minus 20, that goes away. We get negative 2d equals negative 32. Negative 8. Divide both sides by negative 2. Negative divided by negative is a positive, and negative 8 divided by negative 2 is positive 4 days. Again, if this was a test, you would definitely check. 12. Let's see what we buy. Carl, so this is one of those variables on both sides questions. We have Carl and Penny. Carl, you get $2 every holiday card. $2 per holiday card. $2 times the number of cards. That's how much you pay. Plus, there's a shipping fee of 25 bucks. On Penny, it's $5 per card. Here we go, $5 per card plus the shipping fee of 10. Create an algebraic equation, we just did, and then find the number of holiday cards that you're gonna make, which costs the same for either company. So, how many cards would it take? So it doesn't matter which company card I went to. Well, the cereal property, no. Variable combined like terms, no. Variables on both sides, yes. There's a 2c here and a 5c, so let's get rid of the 2c. Minus 2c, minus 2c. 25 equals 3c plus 10. We're going to now subtract this by 10, this by 10. 3c equals 25 minus 10 is 15, and obviously you know. Divide by 3 on both sides, and c equals 5. So if you only wanted to make 5 cards, it doesn't matter where you go because it's going to end up the same. So just let's do a check. Here's my original equation. 2c plus 25 equals 5c plus 10. Let's replace the c with 5, which is what we found. So 2 times 5 plus 25. On the other side, it's going to be 5 times 5 plus 10. 2 times 5 is 10. 10 plus 25 is 35 on the left. 5 times 5 is 25, plus 10 is also 35. So at 5 cards, if that's all you're making, doesn't matter where you go. Most companies will give you the same total cost. Oh, shoot. Let me do, part B says, what happens if you want 10 holiday cards? Let me go back. The one was 2C plus 25, and the other company was 5C plus 10. Well, let's do 10 holiday cards. So it would be 2 times 10 plus 25. And let me write Carl. So this would be Carl's place. 2 times 10 plus 25. 2 times 10 is 20. Plus 25 would be 45. So Carl would cost you 45. But Penny, let's say we're making 10 cards. So it would be 5 times 10 plus 10. 5 times 10 is 50 plus 10 is 60. So at Penny's, if you want to make 10 cards, you would much rather go to Carl's because it's cheaper. Alright. We're going out to eat. Jeff and some friends, they all order the same meal, which is $10.95, plus they all order a drink. So $10.95 times how many people? We don't know, right? $10.95. So a bunch of people ordered $10.95. So plus that same group of people ordered a drink at $2.50 times X. Plus they leave a $10 tip, and all that equals $63.08. You can get rid of the decimals if you want, right? The number of decimal places would be 2, right? Which means we multiply everything by 100 to get rid of the decimals. This one I'm going to keep it. All right, so let's combine like terms. Well, distributed property, no. Combine like terms, yes. So we can combine these two here. If we combine these two, we get $10.95 plus $2.50, which means 13.45x plus 10 equals 63. Well, subtract 10 from both sides. We get 53.80 on the right. 13.45x comes down. Let's divide both sides by 13.45. And let's see if that works. 13.80 divided by 13.45. 45. X equals, there were 4 people. Again, plug it in, right? Do your check and make sure it's the same. There's a bonus question. The larger of 2 numbers is twice the smaller. Well, if there are 2 numbers, right, and one is larger, so there are 2 numbers, and you already know that one is called a larger, so the other one is going to be called a smaller. So let's identify them. So the larger of the 2 numbers is twice the smaller. What do we know about the smaller number? I know nothing, so let's call it x. But I know the larger is what? The larger is twice the smaller one, so 2x, right? Does that make sense? Twice the smaller. Their sum is 3 times the difference. Their sum is 3 times their difference. Find the numbers. So if it says their sum. What is their sum? Well, if I add x plus 2x, it's going to equal 3 times their difference. Find the numbers. Okay, the sum of the 2 numbers is the same thing as 3 times the difference. Find the numbers. Let's see if I'm doing this correctly. So x plus combine. Well, I can combine these two, right? 3x. On the left side, I am going to do distributive property. 6x minus 3x. Their sum is 3 times the difference. What the heck? Their sum is 3 times their difference. Well, if I do, I'm getting 3x equals 3x. Which means that they're same, so x is, well, in this case is infinite solutions. Infinite solutions, I'm going to keep going there. All real numbers. Well, let's see if this works. Their sum is 3 times their difference. Well, let me pick a number. Let's say x is 4, which makes the larger 8. Right. Well, let me do this. That would be 4 plus 2 times 4 equals 3. 2 times 4 minus 4. Let me just see if it works. 4. This is 2 times 4 is 8 plus 4 is 12. Here we have 8 in the parentheses minus 4 is 4, and 4 times 3 is 12. Oh, look at that. It worked. Let me try another number. Because it's all real numbers. Let me try the numbers 8 and 7. Right, so x equals 7, which means the largest. So x equals 7. 7 plus 2 times 7 equals 3. 2 times 7 minus 7. So this is 21. On this side, 14 minus 7 is 7 times 3 is 21. Yeah. And what I should have done, silly me, is combine my terms, right? That's 3x, and that also ends up being 3x. So this is all real numbers. Okay. The answer is all real numbers, where the larger obviously is just twice whatever number we pick. Okay, that's that.